converse of midpoint theorem. So let's prove this. The statement is as such. So we have the line drawn through a midpoint of one side of a triangle is parallel to the other side bisecting the third side. So let's start with the diagram ABC. So we have point P, which is a midpoint, and we have a line which is parallel to BC. So this is a midpoint, so AP is equal to PB. All we have to prove is AT is equal to TC, or let me make this as Q. So all we have to do is make your construction, prove that these two triangles are congruent, okay, and we'll be done. So we have been given, let's consider a triangle ABC. Let P be a midpoint of AB. Then AP is equal to PB. So then we have to prove AQ is equal to QC. Okay, so that's what the midpoint theorem tells. And AP, sorry, one more thing is, actually I missed out one thing. So one more thing is, we have PQ is parallel to BC. So this is one more thing that is given. So to prove is this, and we have construction. Extend PQ to meet T such that CT is parallel to PB. So CT is parallel to PB. Okay, so this is your construction. Now let's think about the proof. How can we prove this? Simple. All we have to do is prove congruency between triangle 1 and triangle 2. Right? That's how we can prove that AQ is equal to QC. So the question is, how will we prove that these two triangles are congruent? Well, we have one angle, second angle, right? Even the third angle actually. All the three angles are equal. If I have one side, we are pretty much done. So which side can we handle? Obviously not AQ and QC, that we can't do. PQ and QT, no way to do that as well. But we can handle AP being equal to TC. How? That's what we have to figure out. So let's consider the quadrilateral PTCB. So what's so special about this? As the opposite sides are parallel, this implies PTCB is a parallelogram. Okay, so this is a parallelogram. So what can we tell from this? This implies PB is equal to TC. Okay, right? So opposite sides of PTCB. Okay, from this, as PB is equal to TC and PB is also equal to AP, thus TC is equal to AP. Okay, so we just proved that the most critical thing, these two TC and AP are equal. So now it's just a matter of proving that these two triangles are congruent. So I'm sure you guys will be able to do that. Consider triangle AQP and triangle TQC. AP is equal to TC. Then we have, okay, we have proved this. So we have to talk about PAQ, angle PAQ being equal to angle QCT, right? Because AP is parallel to TC and these are alternative interior angles. And on the same lines, APQ, right, over here is equal to angle QTC over there. Same reason. So with all of this in mind, what can we conclude? Therefore, triangle APQ is congruent to triangle CTQ by ASA congruency. So with this, we can conclude thus AQ is equal to CQ, CP, CT. That's it. Hence proved, right? So we had to prove this. We have done that.